Why is post-mortem interval relevant in SHC investigations? Imagine discovering a body that seems to have burned from the inside out with no clear external heat source. It's a mystery that sparks curiosity about what really happened. When it comes to spontaneous human combustion, or SHC, understanding the time since death is a key piece of the puzzle. The post-mortem interval, or PMI, is the period between death and when the body is found. This timing helps investigators piece together the sequence of events. If a body shows signs of being dead for several days but appears to have burned recently, it suggests the fire might not have caused death. Instead, the fire could have happened after death, or perhaps the body was affected by some unusual process. Estimating PMI involves looking at changes that happen after death, like body cooling, blood pooling, muscle stiffening, and decomposition. These signs follow predictable patterns, but heat from spontaneous combustion can make them harder to read. When a body is burned intensely, the usual markers might be obscured or destroyed. For example, high temperatures can accelerate decomposition or cause tissue to char quickly, making it tricky to determine exactly when death occurred. Environmental factors like temperature, humidity, and whether the body was covered or exposed also influence these signs. In cases of SHC, extreme heat might distort the normal post-mortem changes, making standard forensic methods less reliable. Knowing the PMI helps differentiate between different scenarios. If a body shows signs of being dead for a long time but is found burned, it indicates the fire probably happened after death. Conversely, if the body was dead only hours before burning, it suggests something more unusual. This distinction is especially important in SHC cases because it can point to whether the fire was a cause or a consequence of death. Sometimes, investigators find bodies that seem to have burned from the inside out, with little damage to surroundings. This raises questions about how the heat was generated and whether it was truly spontaneous or caused by external factors. In these investigations, forensic experts must consider multiple clues rather than relying on just one. They examine bone marrow, remaining tissues, and the pattern of decomposition, especially in areas protected from direct flames. This comprehensive approach helps determine the actual time of death despite the heat damage. The challenge is that standard methods assume normal environmental conditions. When bodies appear to have burned without an external source, the usual rules don't always apply. This makes the investigation strange and fascinating from a scientific point of view. PMI also plays a role in testing different theories about SHC. If evidence shows the person was dead weeks before the fire, it suggests the fire was not spontaneous. But if death occurred just before or during the burning, it opens the door to more unusual explanations. The timing helps scientists and investigators understand whether the fire was caused by normal causes or something more mysterious. Environmental conditions, like rapid decomposition or preservation, also influence PMI estimates. Sometimes bodies are found in strange states, and analyzing PMI helps decide if these conditions are natural or linked to extraordinary events. In the end, understanding the post-mortem interval is vital for unraveling the mysteries of SHC cases. It helps separate accidental fires from more bizarre phenomena and guides researchers toward the truth. When bodies are burned in strange ways with minimal damage to surroundings, PMI analysis becomes a crucial tool to figure out what really happened and whether the case fits into the realm of unexplained physical phenomena or cosmic oddities.